Okay, geometry students, welcome to your 3.1 notes on parallel lines and transversals. The first thing we need to take a look at are these parallel lines, and I want everybody to go ahead and underline the part of this sentence that says that they are coplanar. Okay, that's going to be a critical part of the definition of parallel lines. Okay, so they are coplanar lines that do not intersect. So they gave us an example of line JK is parallel to line LM. All right. So if you take a close look here, let's see if I can use this laser pointer. If you take a close look right here, you can see these arrows to indicate that these lines are parallel. All right. We are not going to talk about skew lines. So if that is not crossed off on your notes, go ahead and cross that off on your notes. For today, we may get to it later, but I'm not sure. So for now, just go ahead and cross that out. And also, let's go ahead and cross off the example that lines L and M are skew. So parallel planes. Let's talk about parallel planes for just a minute. Parallel planes are planes that do not intersect. That may be something that's important for us to understand. And so we have a couple of examples here of some parallel planes. Let's use this laser pointer. We've got some parallel planes. So if these planes are parallel, even though in a two-dimensional space or in a coordinate plane like you would normally see, since these two lines right here look like they would not have the same slope, since they are on parallel planes, they will never actually intersect. That's kind of a strange concept. Anyways, moving on. All right, so let's take a look at example number 1. It says, name a plane parallel to plane ZWX. All right, so we're looking for a plane, and remember we have to name a plane, so I'm going to call the plane that I'm going to name plane, and then I need to use 3 non-collinear points to name this plane. Well, if I'm talking about plane ZWX, I'm talking about this plane up here that is basically the top of this box. All right, so I'm talking about the top of that box. Let's erase my silly lines there that I've made, or my silly shade in that I made. So I need to talk about the plane that's on the other side of the box that's going to be parallel. So I'm going to talk about that as plane. I'm going to name 3 of the non-collinear points. 2 of them are always going to be linear. But I've named the plane TS, so I can either use V or U, and I'm going to choose to use V. Doesn't matter, as long as you're talking about the plane on the bottom of that box that we've created there, or that is there. Okay? Okay, and number 2 says, name all line segments intersecting line segment TS. Now, that's kind of a strange one, because technically any line segment that is going to intersect with TS could really be infinite, because there could be an infinite number of lines that exist. Come on, I'm trying to make lines exist on any of these planes that go down and intersect with line segment TS. And then if you remember our previous unit that we just tested over also, that any 2 planes are going to create a line where they intersect. So also any of the infinite number of lines that could be over here on this plane intersecting with TS, and then we could go off in any direction really from that. But let's go ahead and discuss the ones that are visible because of the points that are indicated on the corners of the box, or the vertices of the box. So I'm going to name line segment ZT. I'm going to name line segment YS. I'm going to name line segment UT. And I'm going to name line segment VS. Where am I going to put that? VS. Right there is where I'll put it. Okay. And if I name all of the line segments parallel to SV, I'm talking about this line right here, this line segment right here, okay? And I do not like my handwriting on that, so I'm going to erase that. But if I talk about the line segments parallel to line segment SV, I could talk about line segment TU. I could talk about line segment V, or that's not a V, that's a Y, X. Talking about this line segment here. I could talk about line segment, I need to call that a line segment, ZW. All right, I've got, let's see, I've got TU, I've got YX, SV was the line in question, I've got ZW, which is on the top of that box, and again, technically I could name an infinite number of line segments if I were to identify points in these regions and then have parallel corresponding points over here on this line segment between X and V, but we'll just talk about the three that are highly visible or obvious because of the fact that there are vertices indicated on the box that we created. Okay, folks, so now we're going to talk about a transversal angle pair relationship. And in this particular case, we've got three lines here that I went ahead and indicated, A, B, and C. And a transversal is a line that intersects two or more coplanar lines. Okay, so in this particular case, our transversal is line A. So in this particular case, our transversal is line A. All right, and we need to start talking about some of these angle relationships. And so I'm going to number or label some of my angles here. So I'm just going to go 1, 2, 3, 4, and 5, 6, 7, and 8. All right, so go ahead and label those on your notes. And so first we're going to talk about interior angles. And the interior angles are going to be between two lines. Between two lines. All right, so a couple of examples of interior angles would be angles 3, angle 4, angle 5, and angle 6. All right, so next we're going to talk about exterior angles, which are going to be outside of two lines. So first we talked about interior angles being between two lines. Now we're going to talk about exterior angles being outside of two lines. So that's going to be angles 1, angle 2, angle 7, and angle 8. Okay, so next we've got consecutive interior angles. We're looking for angles that are on the same side, of the transversal. Okay, we're looking for angles on the same side of the transversal, and the key here is that it's consecutive interior angles. So I'm looking for angles 3 and 5. All right, and that's a pair of angles. And then I'm looking for angles 4 and 6. All right, oops, I should have labeled that correctly. I just wrote 6. It's angle 6. Come on, come on. All right, so we've got consecutive interior angles on the same side of the transversal. All right, if we've got a consecutive interior angle, we could have an alternate interior angle. All right, alternate interior angle. So that's going to be angles on the opposite sides of the transversal. Opposite sides of the transversal. All right, so my angles that are going to be on the opposite sides of the transversal, they got to be listed in pairs. So I would have angle 4 and angle 5. And then the other two pairs would be angle 3 and angle 6. I've got alternate exterior angles, and alternate exterior angles are exterior angles on opposite sides of the transversal. All right, so they're exterior angles on the opposite sides of the transversal, opposite sides. Of the transversal. Okay, so that's going to be examples like angle 1 and angle 8 as pairs, and angle 2 and angle 7 as pairs. All right, and finally we have corresponding angles. Corresponding angles are going to be angles that are in the same position, and they've got to be pairs of angles, angles that are in the same position. All right, so that would be like angle 2 and angle 6. Or we could do angle 4 and angle 8. Or we could do angles 3 and 7. Or we could also do angles 1 and 5. So that one has 4 possibilities, but those got to be in pairs. And so now that we're here, what I want you to do is I'm going to give you guys the opportunity for the rest of class to work on the other side of this set of notes. There's some examples that are going to cause you to think about the things that we've talked about in our notes today. So good luck with those, and I'll see you back at class.